benzaldehydes. What react with the cyanide catalyst. React with the cyanide catalyst. Undergo condensation. Undergo condensation. Forms benzoin. Forms benzoin. This benzoin is also known as alpha hydroxy ketone. Alpha hydroxy ketone. Benzoin is also known as alpha hydroxy ketone. Here we have taken benzaldehyde. Benzaldehyde molecule. Benzene ring having aldehyde substance. Aldehyde substance. This one is benzene ring and aldehyde substance. So it is benzaldehyde. So these two molecules of benzaldehyde in presence of Cn. In presence of
Cn.
Cyanide catalyst. Cyanide catalyst. So undergo heating. Heat ceremony. Undergo heating. OH, C double bond O. So this one is benzoin. This one is benzoin. Alpha hydroxy ketone. Alpha hydroxy ketone. So the product is alpha hydroxy ketone, and this alpha hydroxy ketone is also known as benzoin. So benzene with two molecules of benzaldehyde combined together and forms benzoin. So here it is the functional C double bond. Here is ketone. It is ketone. And the immediate carbon is known as alpha carbon. Alpha. And this alpha carbon having hydroxy substance. Hydroxy substance. Hence the product named as alpha hydroxy ketone. Alpha hydroxy ketone. So mechanism of the reaction. Mechanism of the reaction. So benzaldehyde is also written as C6H5. C double. So nucleophiles will attack the carbonyl carbon because the carbonyl carbon having alpha-linking nature or positive charge nature. So cyanide Cn minus will attack carbonyl carbon and the electrons are program oxygen. Then C6H5 CO minus H and here is Cn. Here is C. Next one, next step. Proton shift. Proton shift. The hydrogen, the proton should be shifted towards to O minus. O minus. And forms carbate anion interval. Carbate anion. So the proton should be shifted, hydrogen atom should be shifted from carbon to oxygen. Carbon to oxygen. Charge and it is Cn minus. Cn. I have this intermediate carbon having negative charge. The carbon having negative charge is known as carbene anion. Carbene or carbanion. Carbene anion or carbon having negative charge. Carbon having then another molecule of benzoin. Another molecule of benzoin. C6H5, C double bond O, H. C double bond O, H. So carbon anion having negative charge acting as a nucleophile. Acting as a nucleophile. Then nucleophile will attack the electrophilic carbon. Electrophilic carbon. So it will attack the electrophilic carbon and electrons are migrating oxygen. Then C6H5, CO minus H, C, OH, CN, C6H5, C6, so C6H5, C6H5, C. C6H5, O minus and a hydrogen, CH. Then this carbon should be attacked on the carbon. So C, Cn, OH and C6H. C6H. Then these electrons are migrated towards and this group should be eliminated. This group should be eliminated. Starting here, C6H5, CH, O minus, and C double bond will go, C double bond will go, and C6H5, C6H5. Here H plus should be removed, and this H plus will be attracted by O minus, and this O minus will convert into O. So here it is. Here it is output. Then one side the mechanism. So benzaldehyde molecule should be taken, and the benzaldehyde Cl minus acting as a catalyst, Cl minus acting as a nucleophile. Here we are adding the catalyst acting as a nucleophile, Cl minus. So it will attack the carbon, electrophilic carbon. So the electrons are migrated on oxygen. Oxygen gets negative charge. Oxygen gets negative charge. So C6H5, C6H5 carbon and CnH O minus, and hydrogen and proton should be attracted by the O minus. Okay, carbon having negative charge. Carbon having negative charge, the carbon is also known as carbene anion. Carbene anion. Carbon get negative charge, the carbon is also known as carbene anion. If carbon get positive charge, the carbon is also known as carbo. So carbene anion, everyday carbo anion is acting as a nucleophile. Acting as a nucleophile. Carbene. Actually, it is a base. What is the function of base? It should attract the protons, but there is no protons in the benzaldehyde molecule. So it will acting as a nucleophile. Acting as a nucleophile. So nucleophile will attack the alcoholic carbon, C6H5 C double bond, carbon acting as an alcoholic nature, and hydrogen. Then the next step, C6H5 CH O minus, C6H5 CH O minus, and C6 carbon OH Cn C6H5 C6H5. Then the electrons of hydrogen atom migrated to the pi bond. So the pi bond is formed with carbon and oxygen. Carbon and oxygen. The protons will be attracted by O minus. Protons will be attracted by O minus. Then C6H5 CH, C6H5 CH OH, CH then C double bond. So carbon is Cn2 should be eliminated because here is a pi bond is formed. Pi bond is formed. So carbon level C is 4. 1, 2, 3, 4. Here is 5th one. It should be eliminated Cl minus because Cl minus is a strong living, stronger living, strong living, and Cl minus should be eliminated. Then the product C6H5 CH C double bond C6H5. So alpha hydroxy ketone should be formed, and this alpha hydroxy ketone is known as benzoin. Okay. So one type of organelle condensation reaction. It is a cross organelle condensation reaction. A cross organelle condensation reaction The all condensation occurs between two different ordinals. Different ordinals. But here it is Kleisel-Schmidt reaction. All condensation occurs between one aldehyde molecule and one ketone molecule. Ketone molecule. So one aldehyde molecule and one ketone. Okay. So aldehydes or ketones which are containing alpha hydrogen atom. Alpha hydrogen atom undergo condensation. Base. So forms beta hydroxy aldehyde or ketones. Beta hydroxy aldehydes or ketones. Once again, so aldehydes or ketones which are containing alpha hydrogen. So undergo condensation in presence of base. Forms beta hydroxy aldehydes or ketones. For example, acetaldehyde CH3COOH and acetone CH3COOCH. Acetaldehyde and acetone react forms CH3 COH CH3 CH2 C double bond O. So beta hydroxy aldehyde. And the mechanism of the reaction. So here we are taking two molecules. One is aldehyde molecule and another one is ketone. So aldehyde CH3COOH. CH3COOH. And a ketone CH3COOH. Among these two reacted molecules, which one is more reactive and which one is more stable?
Aldehyde is more reactive.
Aldehyde molecule is more reactive. Ketone is stable. So, when compared to aldehyde and ketone, aldehydes are more reactive than ketone. Why? Because ketones are less reactive than aldehydes. Aldehydes are more reactive than ketones. Why? What is the reason? So the reason is the carbon is carbonate in both molecules. So carbonate is having carbon atom and the carbon is electrophilic in nature. Electrophilic in nature. This is nothing but positive charge. Here is a positive charge. And the substituents are electron donating in nature. So here it is one electron donating in nature. Here it is two electron donating groups are present. So it is more stable because two electron donating groups are present. It is less stable because one electron donating groups are present. Hence, aldehydes are more active than ketones. So the only reason is carbon is an electrophilic carbon and more electron donating groups will stabilize the electrophilic carbon. Okay? Then, so this CH3 molecule is very active than these two CH3 molecules because it is a functional base. compared to the beta, gamma, delta, so the acidic nature of alpha carbon is more than beta, than gamma, than delta. Then, so here the base will abstract alpha hydrogen. Then CH2 negative charge is formed because the H plus should be removed and the electrons are migrated on the carbon. And CH2 minus should be formed. Carbon anion. So carbon anion is formed. C double bond O H. Carbon anion. Carbon. So what is the charge of carbon anion? Negative charge. When negative charge is acting as a nucleophile. Acting as a nucleophile. Here the carbon anion acting as a nucleophile. Nucleophile. Then it is reacted with acetone. React with acetone. So the negative charge will attach the electrophilic carbon. Electrophilic carbon. Then CH3, C O minus CH3, CH2, C double bond O, C double bond O. So there is an H plus CH3, COH, CH3, CH2, C double bond O. So here is our the mechanism of the reaction involves only two steps. First step, elimination of proton, formation of carbon anion. So the proton from the alpha carbon should be eliminated by the base. So then carbon anion is formed. Carbon anion acting as a nucleophile and attaches another molecule of acid. And it forms beta hydroxy.